So, number one, this is an absolute value equation, and step one on solving any absolute value equation is to isolate the absolute value. And then you want to set up positive and negative situations, and then you want to solve both. Okay? So let's first isolate. We're going to subtract 5. We're going to subtract 5. We'll get 8. You have an equal sign, bring down the rest. You have the 4 out in front, the absolute value, the 2y minus 7. Close the absolute value. And we're still isolating. I need to get rid of that 4. So I'm going to divide both sides by 4. Divide by 4 here, cancels. Divide by 4 over here. You're going to have a new absolute value equation that says the absolute value of 2y minus 7 equals 2. And now you want to set up a positive and negative situation. Okay, so I'm kind of out of space here. 2y minus 7 equals 2. Let me do this over here. 2y minus 7 in absolute value equals 2. So the positive situation will be rewriting it exactly the way it is. The negative situation is writing it exactly the way it is. But you have to flip the equal sign, which is still going to say equal, and then you change the sign of your number on this side, which will be a negative 2. So we're going to end up solving both of them. Let's add 7 to both sides. You'll have 2y equals 9. You're going to divide by 2 on both sides. And yes, we do not get a nice answer. We get a fraction. You could leave it as 4.5. You could leave it as 4.5. Or you could simply leave it as 9 halves. No big deal. Let's look at the other one. We're also going to add 7. Add 7. You're going to get 2y equals 5. You're going to divide by 2 on both sides. Y equals 2.5 or 2.5, or you could leave it 5 halves. On the multiple choice, obviously you're going to have to identify which one they give you. They might give it to you as 2.5, they might give it to you as 2.5, they might give it to you as 5 over 2. Anyways, let's move on to the next one. Let me get rid of these guys just in case we need more space. So the next one is just a regular inequality to solve. So I'm going to distribute negative 3 times 4w, that's negative 12w. Negative 3 times negative 1, that's positive 3. It's a greater than and a 21. So then I solve by getting the w by itself. I'm going to get rid of the plus 3 by subtracting 3 and subtracting 3. I will have negative 12w is greater than, what is that, 18? And my last step will be to divide by a negative 12. Divide by a negative 12. So whenever you're dividing by a negative on your inequality, that's where you have to flip the inequality symbol. So yes, the negative 12 and the negative 12 cancel out. You have w. You have to flip the inequality symbol. And you can't really divide 18 by 12, right? So let's just reduce it. You could reduce by 6 on both of them. On the top, 18 divided by 6, that's really a 3, so you have a 3 left over up on top. And 12 divided by 6 is 2. And of course that minus sign, let's move this minus sign from the bottom up to the top. So that'll be negative 3 halves, your answer. So w is less than negative 3 halves. Of course you could say w is less than negative 1.5 or w is less than negative 1.5. It all depends on what you see on the multiple choice. Moving on to number 3. Find the slope of the line passing through those 2 points. So what you need to understand, you need to memorize the slope formula, and you need to know that this is an x value, this is a y value. Let me make them in blue better. And this is an x value, this is a y value. And this is your first point, and this is your second point. Now once you know that, you could use your slope formula to actually do it. So if we zoom out of here a little, I already have the slope formula right here. It says m equals y2 minus y1 over x2 minus x1. So let me just show my work right here. And I always recommend you start with the division and the subtractions. and then plug in your values that you see. So y2 is negative 2. We're going to type in a negative 2 up there. y1 is negative 2 also. x2 is 7, and x1 is negative 9. Okay? So when we work this out, the minus minus changes to plus plus. And when you add negative 2 plus 2 up on top, you get 0. So your slope for question number 3 is 0 over 16. Now 0 over any number will equal 0. So the answer is 0. Here's something to memorize. If 0 is on top, the answer is 0. If 0 happened to be underneath, then it would be undefined. Okay? If 0 is underneath, it's undefined. Undy. Underneath, undefined. But if 0 is on top, the answer is 0. Okay, let's move on. Number 4, we want to graph y equals negative 3x plus 1. Okay, so let's just first do a quick sketch here. I want to do it right here. Where does this cross the y-axis? Where does this line cross the y-axis? 1. Okay, so let's go to the value of 1 on the y, and let's put a dot right there. Okay? Now from that point, what do? Do I rise or do I drop? Drop how many? 3. And how much do I run? 1. So I'm going to actually go 1, 2, 3 if I actually had those values there. Okay, so let me do that. I'm going to go down 1, 2, 3, and I'm going to run 1. I'm going to put a dot right here. Let me show that 1 right there. Okay, so here is my line, guys. Goes up that way forever and down that way forever. Now, here's what we need to think about. Because it says graph, okay, it's graphed. Let's state if it's a one-to-one function. Do you guys remember one-to-one function? Yes. It has to pass the vertical line test and also the horizontal line test in order for it to be a one-to-one. So is this a one-to-one? Yes. If any vertical line is only going to touch it once. Any horizontal line only touches it once. So yes, it's one-to-one. Okay. What else? Then state its domain and range. Whoa. Okay. Well, the domain are your x values. And let's think about the x, which is really going left and right. Does this line go left and right forever? Yes, yes it does. Yeah, it's going up, but it's still going to the left. It's up to the left. And this one's down to the right. So it really does go left and right forever. So we're going to say x equals all real numbers. And for the range, we're going to say y, and let's think about the range, the y values. Does it go up forever? Does it go down forever? Yeah, it does. Arrow going up, arrow going down. It goes up and down forever. So the range is also all real numbers. Okay? Let's move on to the next one here. Number 5. There's a lot to do here. A lot of operations. We need to follow PEMDAS. So you always start with parentheses. These brackets are like parentheses. So it's kind of like ignoring the outside and just focusing in on the inside. But within the brackets, there's more parentheses. So we're going to zoom in even further just to look at what's in there. So in there, what do I do first? Do I divide, multiply? Yeah, exponents. We're going to do both of these and rewrite everything. So 6 squared is 36. 2 squared right here is 4. And let me bring down the rest. I have the divided by, I have the 3, I have the multiplied by. And I still have the parentheses around here. Anyway, now I either divide or multiply. Which one do I do first? Divide. PEMDAS, the M and the D are both worth the same, so you just go from left to right. So we're going to go with 36 divided by 3. That's really 12. And 12 times 4 is going to be what? 48. So at the very end of it all, inside the parentheses, we have 48. Yay? But now let's zoom out a little and let's see what else is inside these brackets. Okay, so far, inside these parentheses, all of this is really just worth 48. Let me bring down everything else. Let me bring down the minus 2 that's out here. Let me bring down the 20 that's in front of the minus 2. And I might as well close off this bracket down here. So let me close off the bracket. And there's also a bracket outside of the 20. And let's work on that. On the inside, we have subtraction or multiplication. What do we do first? And what's 2 times 48? That's 96, so we're going to put 20 minus 96. Let me write that down. Let me write it in red here. 20 minus 96, bracket. And what is 20 minus 96? Negative 76. And that's inside the bracket. Now, we could zoom out even further and see that outside the brackets, we have this 14 minus right in front. So let me bring that down, 14 minus. And we have a plus 1 at the very end. Let me bring that down, plus 1 at the very end. So what we really have is 14 minus minus, which is really plus 76 plus 1. So 14 plus 76 is 90. And 90 plus 1 is your final answer, 91. You got it? Okay, let's move on to number 6 and 7. Number 6, we have an absolute value inequality. And once again, step 1 on solving any absolute value, whether it's an inequality or an equation, is to isolate it. So I'm going to add 11 to both sides. Cancels, add 11 over here. And I'm going to have a new absolute value inequality. It says 2x plus 2 inside of the absolute value less than or equal to positive 6. Let me take a pause right there for a second to explain this. If this were a negative number, then you could say no solution. You know why? Because if it's isolated, there is no way an absolute value of something is going to give you less than a negative number. If it were negative, you could just stop doing what you're doing and say no solution. But right here it's actually positive 6, and that could happen. You could have a value in here that's less than 6 or equal to 6. Of course, you don't want negatives. But anyway, let's continue by doing the positive and negative situation. Pos, neg. Okay, so the positive situation, you're going to write it exactly the way it is. 2x plus 2 less than or equal to 6. The negative situation, 2x plus 2. We're going to flip the inequality symbol, and we're going to also change the sign of 6 and make it a negative 6. And when we solve the left one, we're going to subtract 2, subtract 2. That'll be 2x is less than or equal to 4. And of course, we're going to divide by 2 on both sides there. Divide by 2, divide by 2. So x is less than or equal to 2. Okay, that's one answer. Let's do the other one. We're going to subtract 2. Subtract 2. We're going to have 2x is greater than or equal to negative 8. We're going to divide by 2 on both sides. So you will have x is greater than or equal to negative 4. However, we need to decide if this answer should be written with the word or right between it or together as a compound inequality. And the only way to determine that is to actually think about the number line and see how they're graphed. So the easiest thing to do is so these are our answers, but the question is we don't know if we're going to write them together or apart. Let's go to a number line. You're going to do a quick sketch of a number line, and let's put on a number line the smaller number on the left side, which would be negative 4, and the bigger number, which in this case is the positive 2, on the right side. That's right, I said right. Anyhow, when we look at this one right here, what does it say? It says x is less than or equal to 2. Okay, here's 2. Less than or equal to a solid dot, less than's to the left. Okay, the other one says x is greater than or equal to negative 4. So greater than or equal to solid dot, greater than's to the right. Bless you. So what do we know, guys? We know that the areas are together. They're together, not apart. Now, if they were apart, I would just put the word or right between it and I'd be done. But since the areas are together, you have to actually place them together as a compound inequality. Now, putting them together, if you already did the number line, is cake. Why? Because all you got to do is put the x in the middle and just bring down your numbers. And since the smaller number's on the left and the bigger number's on the right, it has to open up to the right. Like that. Now, of course, these were or equal to, so put the line underneath it. But that's your final compound inequality answer right there, written together. I'll do another small video for that last one on the opener.